This is Human Factors in AI, final project submission for Sean Ryman. The purpose of this artifact is to address the issue of arrival prediction uncertainty for inbound supply shipments into e-commerce supply chain fulfillment centers. We discuss a proposed approach to using machine learning to improve accuracy as well as increase automation of the process to drive down supplier customer churn and improve economics. This is the same project that I applied to the last module, and so I will skip the most of the problem statement here. But the specific user for this task, when focusing on this area, is the supply chain inbound planner. The role is to provide predictions to other functions in the supply chain so that downstream teams can plan for inbound volumes to ensure that they are received on time. The specific task workflow is below. This all starts with a trigger, which is an event detected in the inbound shipment for an inbound shipment. So the shipment's created, milestones have been passed, disruption events occurred. When that happens, the user needs to review the anticipated time of arrival based on the latest event. They're going to use that in a basic heuristically timed model. They have to decide when they look at that output if it's correct based on their understanding or not. And then the action that they're going to take is to finalize that arrival date, communicate that to downstream consumers, and really provide that in an inbound forecasting spreadsheet. The consuming team then is going to look at that and decide what they want to do for labor planning. They're going to put those labor plans into a planning system, and then if everything goes well, the right number of containers arrive to align with the planned labor and everything works fine. As you can see from this flow, there's several human judgment steps as well as use of manual tools to facilitate the process. There are multiple places for error to be introduced at the time that communication is slow. It's not clear how humans make these decisions, so there's no way to trace back errors to make them better over time. It certainly is not possible to include all the factors in that analysis. From user experience design perspective, thinking about the user inputs and feedback loops, it's meant to ingest high amounts of data and automate a process. So we want this to be a mostly machine-driven flow. We want this to be in a continuous fashion. We want users to see what's being predicted from a forward-looking horizon, but also where error is occurring on those existing predictions. Understand that there's some non-public information here, and so we want to have the ability for users to create an override if they see fit. The main issue with that is having these overrides create bias and error in the model. We need to consume those overrides and label them so we know how to create a feedback loop there. From transparency, we expect users and operators to be highly skeptical of the results. We'll create dashboards and show metrics, input data coverage, and input data freshness so that users understand the foundational data of the model. Also, publishing historical accuracy metrics will be critical as well to help them build confidence versus their existing heuristic benchmarks. Communicating uncertainty for downstream operators to react. It's helpful for them to understand what direction we expect the probability of miss to be. So, for example, if we're predicting an arrival to come in on a Wednesday, but we believe it's more likely if it misses to be a Thursday or Friday than it would on a Monday or Tuesday, operator may be more conservative in planning their labor and not really aim for the beginning of the week when maybe more likely to be at the end of the week if there's a kind of a borderline decision that they have to make. From a privacy perspective, I don't really think that there's any specific laws at play here, although a lot of the operational teams involved in this process could be unionized, and so some of this data could be sensitive to them. So we definitely wouldn't want it getting out. We'd really want people inside the company that had signed NDAs and had the right level of security to have access to the data, but no other specific concerns other than that. From an ethical perspective, I expect bias to be a risk for this model. The historical data will be biased due to various shocks that have happened in the supply chain over time. It'll be important to get the right labels in the right place to be able to pull those out. Additionally, human errors in the data at various points in the journey, whether they processed a container correctly or not. And then As I said previously, as we allow humans to put in overrides, we need to be able to measure those overrides to see if they're improving or degrading accuracy. Accountability and transparency would be critical in getting operators to accept these. Um, we want people to not believe that their jobs are in jeopardy for automation, and we need people actually in these roles to look at the machine outputs, um, look at the counterfactual data to understand them, and then really deep dive the sources of error that are produced by the model so that they can go backwards up the supply chain, find where the error issues are in the process, and then go ahead and fix them.